Cohere has introduced Command A, which is their latest large language model. And the tagline over here is max performance, minimal compute. So, what they are claiming over here is that this particular model, when compared to leading proprietary and open weights models such as GPT-4o and DeepSeek V3, it is much more faster, it is much more efficient, and it also has similar or better performance. That is what they are saying over here. Okay, so Command A matches or outperforms larger and slower competitors while offering superior throughput and increased efficiency in when they evaluated, in a head-to-head human evaluation across business, STEM, and coding tasks. That is what they are saying over here. If you look at the output tokens per second for 1K context, if you see Command A, this is 156, GPT-4o November version is 89, DeepSeek V3 is 64. That is what they are saying over here. Right, and across standard benchmarks like instruction following SQL agentic tool tasks, basically across standard benchmarks on MMLU, math, or any of these benchmarks, they say that this particular model provides strong performance. Now, this is a model which is targeted towards efficiency. So basically, you can serve this model on just two A100s or H100s. It requires less compute comparable to the other bigger models. Okay, and it is much more faster in terms of tokens per second. It is 1.57x faster than GPT-4o and 2.4x higher than DeepSeek V3. Also, private deployments of this model can be up to 50% cheaper than API-based access. That is what they're saying over here. And it supports 256K context length, almost twice the most leading models. It can handle much longer enterprise documents. It has Cohere's advanced RAG with verifiable citations, agentic tool use, enterprise-grade security, and strong multilingual performance. So this is more of an LLM targeted towards enterprises. It supports 23 languages spoken by majority of the world's population. It has expanded enterprise-level support. Okay, they also performed extensive human evaluation and found users strongly preferred Command A over DeepSeek V3 across most languages on a range of business use cases. So it is mostly a model targeted towards enterprise users. Okay, and it will also work with their agent platform. That is what they're saying over here. So this particular model, you can go and try it out in their playground. This model has also been released on Hugging Face, provided that you cannot use it for commercial purposes, you can use it for research purposes. So they have a demo. This is a 100 billion parameter model. It has 256K context length. And they have a Hugging Face space where you can go and try out this model. You can try out there, you can try out in their playground as well. Okay, Cohere playground or the Hugging Face space. So I just tried out this model on the Hugging Face space. So if you look at over here, I tried a couple of use cases. What they're saying is that this model is now improved on math, reasoning, okay, so and coding. So I thought I will try out some of these use cases. So I gave a particular problem from this hardest math problem for SAT exams. Right, so this is the problem which I gave. So this is the equation which shows how temperature and Fahrenheit are related to each other. Temperature measured in Celsius, temperature measured in Fahrenheit are related to each other. So based on this equation, which must be true, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5 by 9 degrees Celsius, which is true. If you put 33 over here, a 1 degree increase in Fahrenheit, now this will be equivalent to 5 by 9 degree increase in temperature Celsius, right? Because this equation. Second is a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 Fahrenheit, which is what you get when you reverse this equation basically. And the third is false. Okay, so which is the exact thing which I tried over here by pasting it over here. So the answer is actually D. So it says how to determine it given this equation. The first statement is a temperature increase of 1 degree Fahrenheit is equivalent to temperature increase of fraction, basically 5 by 9 degree of Celsius. So it checks it and it says that yeah, this is true. Right. Similarly, for the second statement, it says that it is true. It solves this and it says that yeah, this is also true. 9 by 5 basically, which is 1.8, so it is true. The third statement is not possible because the first statement is true. So it gives the correct answer. Okay. So this was one math problem which I tried. There was another math problem over here. Okay. This problem is about there are 2 points A and B which lie on a circle with radius 1 and arc AB has a length of pi by 3. What fraction of the circumference of the circle is the length of the arc AB? Okay. This AB arc. So this is the problem which it needs to solve. So it says what is the formula for circumference of a circle, formula for length of the arc, okay, which is given by r by theta. So here the length of the arc is given by pi by 3, determine central angle. It does all this calculation and finally it says that the answer is 1 by 6, which actually matches this over here, right? Now it could be very well the case that these problems are already present in the training data. You never know, okay? But it was able to generate the correct response over here. right? I tried a small language translation task where I wrote my name in Kannada, Nanna Hesaru Ritesh basically, and asked it to convert it to English. It is doing that translation quite well. I wrote another translation of, like basically I wrote in Kannada, my name is Ritesh, I create videos related to AI on YouTube. That is the Kannada text which is present over here. And I asked it to translate to English. It is doing it properly, right? So it supports multilingual languages. You can also check out its language translation capabilities. Then I gave this simple thing which is about, explain Newton's law like I am 12 years old. Not like I'm 5 or something like that. So Newton law in super simple way, like 12 years old. Imagine you are playing with toys or riding a bike. So here is the first law of inertia. So it gives saying that, like, stuff stays still unless something makes it move, and stuff keeps moving unless something stops it, which is your first law of this thing. It gives a nice explanation of, imagine you are playing with a toy car on a smooth floor. It is just sitting there. It won't start by moving itself. You need to give a push. Once it is moving, it won't stop unless something stops it, like a wall or your foot. That is the inertia law. Okay. The second law is law of acceleration. The harder you push something, the faster it goes, but it also depends on how heavy it is. So force is equal to mass into acceleration. So it gives, like, think about kicking a soccer ball. If you kick it lightly, it rolls slowly. If you kick it hard, it goes fast. But now imagine kicking a bowling ball. Even if you kick it hard, it won't go as fast because it is heavier. So it gives a nice explanation. Okay. And the third law is, for every action there is an equal and opposite reaction. So it gives the example of, you're jumping on a trampoline. When you push down on the trampoline, action, it pushes back reaction. Or think about swimming, you push the water backward, water pushes you forward. So it gives this nice explanation. Okay. Then I gave it a coding problem. So basically, this is a problem which I pulled from LeetCode. Okay. So this is about finding all anagrams in a string medium. This is a medium leak problem, what you call LeetCode problem. Given two strings, return an array of indices of anagrams. You may return the answer in any order. For example, if you have this, this particular string CBA, EBA, BACD, and your input string is ABC. So CBA is an anagram of ABC. It starts at 0, and again, BAC is an anagram which starts at index 6. Okay. So I gave this particular problem over here. It actually gave me the code, and the best part was in the example, right? It gave the same example. That was a bit surprising for me. Again, it could be that this problem is already present in the training data. So I copied the code and I ran it over here, and it got the proper, output basically. But it was the same input, which is present over here, CBA, this exact. So maybe it's trained on, I'm not sure if it is, already present in the training data. Okay. Then I wanted to try some logical reasoning problems, like your trolley problem dilemma, which is about imagining a runway trolley circling down a track towards 5 dead people. You stand a divert a trolley onto another track where one living person is tied. Do you pull the lever? The classic trolley problem for reasoning. And here it says that, whatever is this thing lever you pull depends on your ethical framework and personal beliefs. Universally, no right answer. So it gives a proper answer over here depending upon the different perspectives of looking at this problem. Okay. So basically, there is this collection of misguided attention, a collection of prompts to challenge the reasoning abilities of large language models in the presence of misguiding information. Okay. So here you have nice examples of, various problems where LLMs can get confused. Okay. For example, this measuring 6 liters, this traditional measuring problems, right? So this is an interesting problem. I have a 1 and 2 liter jug. I want to measure exactly 3 liters. Very simple. Pour the liquid into 1 liter, pour it into a container, pour it into another 2 liter, and pour it into a container, right? You have 3 liters. Very simple as that. Now, if you ask the same question to your LLM, you see the amount of text it generates, it kind of gets confused. It starts creating lists like, okay, fill the 2 liter jug completely. Now you have this. Now again, pour it into 1. Now you have 1 liter. Kind of it goes into this thing before giving the final simple answer. The simple answer is fill 2 liter jug and pour it into a container. Fill 1 liter jug and pour it into same container. You have 3 liters now. As simple as that. But then this is the thing called misguided attention, right? How LLMs struggle with these problems. Okay. Another simple this thing is this. You are in a room with 2 doors. So there is misguiding information. Sometimes clear information is present, but the LLM is not able to understand it. For example, you are in a room with 2 doors. One is unlocked and leads to freedom with a large exit sign above it. The other is other to certain doom and is therefore locked. There are 2 guards. One always tells the truth, other always lies. You don't know which is which. You can ask one guard one question or just leave. What do? You basically just leave. You clearly have a door which says exit sign, right? So you just go through the door. But here it goes against like the classic logic. Ask either guard. Then here it is work. If you ask the truth teller, they will truth tell this thing. What the liar would say, which is the door to doom. It kind of both cases the door they indicate is one leading to doom. Simply choose the other door. Okay. So this is what another example of just use the exit door. That's a simple answer. But LLM would strike up an unnecessary discussion. Okay. Similarly, in the previous case of liters, LLM would start creating lists and it will try different things. Okay. So these are some logical reasoning problems, and I happen to find out this nice, misguided attention collection of prompts to just evaluate reasoning abilities of large language models. Okay. So these were some examples which I tried over here. So you can also try out this model. This model is mostly targeted towards enterprise customers who want smaller, efficient, large language models giving similar performance to a GPT-4o or a DeepSeek V3. So that is what is the target of Cohere over here. But you can also download this model, and if you have sufficient hardware, you can run these models and for research purposes basically. I hope this video is useful. If you like the video, please like, share, subscribe to the channel. See you in another video.